In this lecture, we see how to find effective focal length when two lenses are thin lenses or coaxially placed. Okay, they have same axis, two thin lenses. Suppose if they are in contact, then we have 1 by f is equal to 1 by f1 plus 1 by f2. What is f1? Focal length of one of the lenses. f2 is focal length of the other lens. F is the effective focal length. This formula is true when the two lenses are in contact. When the two lenses are separated by a distance, we see how to write the formula. So, let's say this is one of the lenses, say L1. Let's say its focal length f1, this is the optic center, this is the axis. Okay. Because we are going to deal with the focal length, let's say the incident ray is parallel to the principal axis and close to it, paraxial ray. It will pass through some point on the axis. That point will be principal focus. So what I do, I just draw a line like this, and it is cutting the axis here. Okay. Just take it as say O1. I just give some arbitrary symbol, say A. Of course, O1A is f1. A is the second principal focus of this lens. Natural, a ray parallel to the axis after refraction will pass through the principal focus. Okay, this is quite obvious. Now what do you do? I just write it here. O1A is O1A is f1. Okay. Now consider or extend the incident ray which is parallel to the axis. Now this is called deviation, delta 1. Actually, what is the deviation? It's an angle. What is the deviation angle? Angle between the incident ray and the ray after refraction. The deviation in the path of the ray. See, the ray tends to go straight, but because of the presence of the lens, it has turned. How much it has turned, that what angle through which it has turned, that is deviation. So deviation by the first lens is delta 1. Okay, and deviation by the second lens, this is I write here delta 1. Deviation by the first lens. Deviation means deviation angle or angle of deviation by lens L1. Now let's say you have another lens here, say L2. Okay, optic center, they are coaxial. This lens is L2. Because of the second lens, the ray will be bending further so that the image is brought closer. So somewhat it will be here. If the L2 is not there, image is formed at A. Because L2 is there, image is formed at B. Right? Now deviation produced by the second lens is delta 2. Because without the second lens, the ray will go straight. Since the second lens is also there, the ray bends further. So delta 2 is the deviation by L2. Deviation by lens, there is a formula, general, h by f. H is the height at which the ray is incident on the lens from the optic center. That is, this is h1 if you take. Deviation by this lens is h1 by f1. Consider this to be the second lens whose focal length is f2. So deviation by the second lens is h2 by f2. Formula is same. Deviation by a convex lens is h by f. Whatever may be the incident ray, if h is the height at which the ray is incident on the lens, the height is measured from the optic center and f is its focal length, then delta will be h by f. That is the formula for deviation. Total deviation delta will be delta 1 plus delta 2, total deviations. This is by delta, this is the deviation is delta 1, it is further deviated by delta 2. I extend this ray backward. I extend this ray backward. Okay, you consider this point as C. So if this is delta 2, this also will be delta 2. If this is delta 2 here, because they are vertically opposite angle, delta 1, delta 2, this will be the total deviation. Why that is total deviation? See, imagine the effective lens to be here. Incident ray parallel to the axis is coming, deviates, final image is formed at B. So if you have one single effective lens here and the incident ray is parallel, it refracts, okay, and the ray is passing through the principal focus of the effective lens. So what is actually B? B is the second principal focus of the lens combination. Not B is not the principal focus of this lens alone. It is the principal focus for the effective lens, single effective lens. That means that lens can replace both the lenses provided it is placed in proper location. Understand that. Therefore, delta is the total deviation which will be equal to delta 1 plus delta 2. Exterior angle is equal to sum of the interior opposite angle. Or otherwise you can use the logic, first lens deviation delta 1, second lens deviation delta 2, total deviation delta 1 plus delta 2. Okay, here. Now what you will have to do is very simple. After this, delta is equal to delta 1 plus delta 2. Delta is h1 by f. Delta is, that is for this, imagine the ray is coming parallel to the axis, deviated by delta. So if this is h1, this also will be h1 by f. This is the effective focal length. I'll draw it and then rub it off if the diagram is too congested. This is f because this is effective focal length, this is h1. The ray is parallel, incident on the lens, passes through its principal focus. So what is, the lenses are separated by a distance d, two lenses are separated by a distance d, and you consider this as say some E. EB is the focal length, effective focal length. EB is the effective focal length. So H1, imagine there is a lens placed. This is delta, because this is delta means this also is delta. So delta is equal to H by F. That's what I said, no, for the lens H by F will be the deviation. Already I told you. Okay. So H1 by F for delta, delta 1 is H1 by F1 plus delta 2 is H2 by F2. Okay. Now we can see in this picture, H1 is this that we know, H2 is this distance, So here what we can do, you can use properties of similar triangles. Consider this triangle. So there are two similar triangles, F and G. I call this as F, call this as G. Okay, this is H2 by F2. O1FA, one triangle. The other similar triangle, you take this GA or O2GA. Just clearly look at the diagram. This is a crucial step. O1FA, what is A? The A is the intermediate ray. Of course, I just initially showed with broken lines. In the absence of the second lens, the ray will reach this point A and of course pass through it. So O1FA and O2GA are similar. So we can write H1 by F1. Note that O1A is F1. O1A is F1. H1 by F1, this is H2. H2 by this distance, all the way from here to here, O2A. But O2A is nothing but F1 minus D, because this distance is D. This is F1 minus D will give you O2A. So this is F1 minus D, which gives you H2 is equal to H1 by F1 into F1 minus D, that is H2. So now take this equation, H1 by F, we want to find F in terms of F1 and F2. H1 by F is equal to H1 by F1 plus H2, for that you use that H1 by F1 into F1 minus D in the numerator, this F2. Now H1 is getting cancelled. So 1 by F is equal to, I think I can write here, 1 by F is equal to 1 by F1 plus 1 by F1 F2 into F1 minus D. So 1 by F is equal to 1 by F1 plus F1 cancel, I am expanding, F1 will cancel, so 1 by F2 minus D by F1 F2. D by F1 F2. This is the formula which gives effective focal length F. Okay, you can easily check this. Suppose if the two lenses are in contact, D is 0,